It should be on, I believe. I see people in the stream, so
Yeah, my bad. What's up, people in the stream? Okay, let's go.
all
Can
right, let
see
me
the
get
chat.
my chat back up. Okay, cool. All right, so first question I had, this is the main one, and I don't know whether you guys even know like this level of granular detail. Like I don't know how you guys are using the models, but basically tokenizer questions. Like, do you guys know, like, are you guys allowed to tell us what tokenizer you're using, or is it something you guys like trained yourself basically? And if so, like, my biggest questions are, number one, can we have access to it? And number two, are you guys allowed to talk about like I guess what I would say is there like a cutoff limit? Like, does it concatenate somehow the input I'm putting into when I make a prompt?
Yeah, so I think I'm guessing a lot of the answers to this stuff are going to be like it more focused on like what you're trying to get out of it,
Right.
I would say.
That's
So I think
fine.
the short answer is like we don't. It depends on which part of the system you're talking about, but like in general, we are actually just learn our own tokenization from a very simple encoding.
Okay,
And
gotcha.
so our model learns what it needs to like in the loop. And
I
that's one of
see.
those things where as when we had a first kind of hobby project, it was like, okay, we're going to use stable diffusion, a bunch of off-the-shelf components, just like see what the heck works. Can this
Right.
image thing do
That was just clips, so
whatever?
that was very straightforward. Um,
That was clips and everything was like off the shelf. These days, it's like, we're in the game of making the best music model in the world, and everything, the scale and all the little details are much more important. So the system
gotcha.
is in some ways more complex, but in some ways it's less complex because instead of like using a bunch of components, you can kind of learn more altogether when you have a large kind of system that learns well. And so. I know the question is about like as it relates to prompting and what gets tokenized and stuff.
Right. That would be my
So
main question. Is like you guys have a
yeah,
huge context window when I'm putting a prompt. I can make a massive prompt. Some part of that gets ignored at a certain point. I think it's like a direct cutoff from what I can tell because I've done A/B testing with like same seed. I just haven't bothered to like figure out whether it's token count or character count or whatever. But basically, I'm just curious like when does it cut off, and if there is some sort of a concatenation, or if it's just like all going in together, like one of the newer or newer process text processors, where they can take a lot at one time, whereas the ones I'm using on older models, there's a limitation, and they kind of have to use certain tricks.
yeah. And you're talking about the sound prompt mostly, not the lyrics.
Yeah, so all right, here, I think it'll be easier if I explain the reasoning behind why this is important. So an
Yeah.
example is with, since you guys did this using SD 1.5, you're probably relatively familiar with SD 1.5, SD 1.5 prompting, I'm going to guess. So I'll start with that as like a sort of point of comparison. Basically, if you have a prompt, for those watching, right, SD 1.5, as I mentioned, I believe it used clip. I mostly use SCXL, but I believe it used clip. If I remember, that has a 75 token sort of like window in which it's able to view your prompts. But you may say, well, Daniel, Yolkhead, I put in massive prompts sometimes into STXL. It seems to work fine. Well, what it does is it takes that prompt, whatever engine you're using, whether it's Forge, A1111, or you're just using an online front end for it. It takes that and it's going to break it up into chunks, and it combines these chunks together. So one of the methods I use, just as a quick and dirty method, rather than me having to use an LLM pipeline to enhance a prompt and expand it, basically to make it more dense and more meaningful to the model, a quick and really dirty way to do it is you just copy paste your prompt over and over. And what that does is it rolls the context window across your prompt. In a very mature model, it's seen enough such sections over the course of a bunch of people contributing to the model and fine-tunes that actually becomes extremely useful and usually adds better understanding of the model without you having to do anything else. And so you'll usually get a better win rate. Basically by, let's say it's 120 tokens, you'll have to do a little bit of math, but if you have a 120 token prompt, then you have 75 token chunk, 75 token chunk, you basically have a remainder. And so the rest of your prompt, when it continues, gets stuck into that remainder. And each time, each 75 token chunk actually looks at a different prompt in essence, even though it's the same prompt. And so basically that's where my question is geared towards is this a method that's worth I mean, obviously it's going to use more compute for y'all, so I don't want to, but is it a method that's worth using? Does it actually have effect on yours, or is it just basically blowing smoke?
Yeah, I mean, I think, everything is worth testing and using. So I think like empirically, if this stuff works, then it's
Well, that's the problem. It's tough to
like
tell, but yes.
useful.
I guess I could try
And
it with a single seed, but yes.
well,
Okay.
no, I think the point is like everything, like the I can talk about like how we the options of when we're training a model and thinking about sound prompts. It's like you can either aim to have everything as structured as possible so that the model gets, a structured input.
Right.
And then every time someone puts something in, it's like either you want them to use that structured input or you try to remap stuff automatically into that structured input.
Right.
The alternative is that you train the model to be able to handle lots of different structures of things, and then it's more free form.
Yeah.
And then whether somebody wants to do um, a crazy Daniel prompt with a
Right.
fake biography of a musician, or someone
Right.
wants to type in
That's
a
actually
sentence like
Alex. Got to credit him.
that. Okay, all right, credit to Alex. Um, and you could have someone that's like, oh, I want a song about this and this and this, and it's very like sentence form, or you could just have like uh, genre, comma, instrument, comma, emotion, and
Right.
that's your prompt. So our approach is more like we actually try to add the diversity when
Nice.
training so that the model is like seeing all these different angles. But the thing worth realizing is just like deep networks, like we are in the business of training large diffusion transformers,
Okay.
and the overall system that generates a song is like it's quite comprehensive. Like the simple ideas of diffusion are actually like beautiful and elegant,
Right.
and I
But the
love
dirty
thinking
of
about them.
it.
The whole system is there's a lot of stuff in the soup.
I believe that.
And
Yeah.
so the result of like what makes the black box like it's not a black box to us, obviously. Like we
Right.
made it, we understand lots of parts of it. But at the end of the day, like when you have this scale of a model, it's understanding what works empirically is super useful. And
Yeah.
the most interesting thing here is like these things, like when you're training it, it's kind of a conditional problem of like it's trying to guess what is likely based on the inputs that you've given.
Right.
And when you are generating, you are trying to generate something interesting. And the more interesting and on the fringes your prompt, the more you're going to get outside kind of the modes of what tend to be common.
Right.
And so something as simple as like, I want more of something, therefore I'm going to copy paste it 10 times.
Right.
Like in my mind, that's a fine thing to try, and that's way less crazy than I'm going to take the weights of an anime model and the weights of a, noir model and average them and kind of get outputs that combine both. Like that is literally insanity. But that's the kind of
Believe it or
high-dimensional,
not,
like,
believe it or not, I just got done averaging about 32 models down into a model that
yeah,
I'm running
I
at
believe
100 CFG right now. With
100 CFP is literally insane. Why,
I
why
can
are you
go
doing
above
that? What
100
are you,
CFG. I gotta code up so I'll get into that. But it has to do with so another add-on to the negative method I've been using, and I'll go into that on another thing that's irrelevant here. Or we can talk at the end if we have extra time about whatever.
can I
Um,
suggest like I don't know if there's a way to share my screen. I just have one GIF that I think is really interesting.
While
Um,
you're finding that, I will share with you. So 100 CFG, just why that
yeah,
sounds odd is, so if you think about it, the models are mean reverting. So you end up having to crank CFG if you're doing like a tiered tree of models that ideally have been fine-tuned on totally different data sets, and then basically you're preference optimizing the end model in a very indirect way using basically the categorization of whatever site you're getting the models from, alongside maybe your own knowledge of the different models. But by the time you get to the end, only the traits that are in common are going to be reinforced, and it's still going to be weakly in comparison. to normal. On top of that, of course, you're 100% right. Like if you just merge two models like on simple average, you're going to get garbage results. The idea is you do this with enough models and you have enough mean reversion, it actually ends up becoming coherent. And it's very coherent. As I'll publish that model with my next album. I've done a few of these ones. But if you just do a small amount of merges, it doesn't work well. It has to be with a large aggregation, which is most of what I do, is the idea of aggregating a lot of different methods at one time to get a good result. But yeah. Anyway,
let me share this because I think like you're a mad scientist with these types of models, and I think most people watching this, are probably like they're just making music. So
right. Well, there's a lot. You'd be surprised, but yes. Well, there's like dozens.
There's a lot.
There's dozens of us.
There's dozens. So this is just like my favorite image ever of diffusion, and this is a very simple example of like. You have a spiral distribution, and you can think of the spiral as like the space of all possible interesting audio or images or video or literally anything. And we are trying to map that distribution. And to do that, we're kind of starting with the easiest distribution that we know the most mathematical properties about, which is just a Gaussian normal distribution, which is just like blobbed around the center. And so these dots are samples from that distribution,
right.
And each dot is kind of evolving into the eventual distribution, which is like somewhere on a spiral.
Right, human preference, in essence.
And it's basically like, this is like unconditional diffusion. This would be like, I have this like data set of images that I want to map. Mm-hmm. And each one of these data points is a random noise that evolves into some location on the spiral. And this is one of the best ways that humanity's found to basically model a natural data distribution. And this by itself isn't that awesome because you can't control it at all. It's kind of unconditional. So then you start doing stuff where you now say, well, maybe I tell it I'm in the northeast quadrant, or maybe I tell it this image has yellow in it, or maybe I tell it there's a dog in the image. And you start getting more and more advanced, and then you start like playing all these inference tricks and guidance. But the beauty of this image is just seeing like how seeing the evolution of this is essentially like the diffusion model is learning a differential equation, and the differential equation is basically like what direction to move. Right. So we're moving from like a time step that is fully a noise to a time step that is fully noise. A sample of the data.
Right.
And during that schedule, you can take a bunch of steps, but those steps are basically just the model is telling you move this way,
move
this
direction,
way, move this
100%. Right. It's a direction.
And when you ask the model, what direction should I move? And by the way, it's not just move me towards a direction that's going to make a good image, but move me towards a direction that's going to make a good image and have a dog in it. It'll give you a different direction.
Right. And the direction space is extremely complex. And this, it's a huge, this is what he's talking about. If there's, we got people in here. Is like basically, I think one of the most useful ways to think about music generation, or really any sort of creative generation using generative AI tools, is spatially. Basically, he's describing a spatial, and you'll talk to anyone you talk to who uses AI a lot for generations does this. They start to think about as like almost like exploration, where you're trying to move in the right direction, and basically most of your methods are sort of every time you move, which is basically a generation, you have like an approximate. You have a certain window to where you're going, and basically you're always trying to narrow that window. And make it more accurate. And that's when people talk about win rates, that's basically what we're talking about, is to get the result that you want. The whole time you're trying to, number one, eliminate bad results. That's one way to get yourself in a better direction, negatives, in essence, which is something I'm big on. And then positives, finding prompts or methodologies that will push you in the right way, which some of that is on their end, basically training a better model, making it a better generalizer, getting a better human preference data, and just all around being cool guys and girls. Hi, Kendall. And the other part of it is, of course, on our end, finding cool prompts and understanding the model, learning how to communicate with it. Like you said, if it works, it works. What empirically works is what matters. when you're dealing with the models, a lot of things will come up that are unexpected, and being able to roll with that is definitely super important. So yeah, in my case, what you were talking about, typing like solo 8 times or any of these sorts of things, everyone has been doing this for some time on most of these, just getting outside the normal prompting sphere. But that was one of the questions actually I wanted to ask you about, was y'all's whether you guys use natural language and basically try to get a more comprehensive caption for your data. And it sounds like you already kind of answered that. But I guess my question go ahead. Well, I guess my question would be like, how deep does that go? Like can I prompt, like, I guess, well, the thing is, when you do it like this, you really can prompt anything when it's this unstructured, which is what I really like when you combine tagging with natural language. But if you don't, I don't know if you guys can tell us this, but was there a particular model that captioned it? That could be useful, because then I can replicate the results from that model and do multiple things with it. Like, not replicate the results, but I can put my audio into that model, get it to describe the audio to me, and then in turn put that into Riffusion, and that can be helpful, both as a negative sometimes and as a positive. But if you can't tell me, that's also okay. Just worth asking.
The answer is essentially there is not one model that's like this. We run things through this model and then it captions things,
Right.
and then there's many sources of captions and different ways of kind of augmenting them. And I think another core thing is just like the model, like this is when you get to a large scale of models, like this thing is learning language from scratch. It's learning
really?
how to talk. It's learning pronunciation. It's learning the meaning of words and the relationships between them. Like it is essentially just like it has a deep understanding of stuff. And so at some level, it's like the model itself can interpret different
Language.
structures, things. So it's not so
Interesting.
guaranteed that like, oh, matching this type of structure will work better. It might. These things are always getting better, and there is no way to. Yeah, I think trying to hone in on like this exact structure of thing, like,
Right.
is the way to go about it, and this is the one way to do it, is probably kind of troubled,
I agree.
especially when you add in like multiple guidance of multiple sound prompts
Right.
and negative prompts and vibes and the advanced sliders and more advanced ways of control that kind of we'll have
A
in the
stronger.
future. Like it
Yeah.
really is like, the way I think about it is like like the spiral example is in 2 dimensions. You have an XY coordinate, but the Riffusion example is in like a very high number of dimensions, but it's kind of like the spiral, just in very high dimensional geometry. And I
Right.
love geometry. I'm a geometry guy, and all these things are just kind of like a lot of the intuition about the model comes down to how very high dimensional geometry works,
Yeah.
and the craziness that is like averaging model weights or like using negative prompts to move away from something and adding that to a positive prompt and getting something in between, like
That's
that's just the core beauty of deep networks that
yeah.
makes it all work. And I think the like contents of what's in your text prompt there and the exact formatting is like, it's definitely important now, but I think it's probably not something that's like the future of things, like in,
Well, my main reasoning behind it is actually to invert it. I just didn't want to be rude. Generally speaking, if someone uses an LLM for a particular captioning, there's going to be overfit in it's going to be stuck on certain patterns. It's the same way, like I'll
Yeah.
put so the idea is to put that in your invert. I do that with Suno because they have a thing that basically takes your prompt and turns it into like an advised prompt, and I just invert that prompt and then go back to my
Like a
original
helper.
prompt. And it gets me oftentimes out of ruts that otherwise would be in, or gives me just directly higher sound quality by inverting the prompt that's recommended. Just a tip for...
So let me try to understand that. Like, they have a tool where you type in a prompt and then it turns it into a
Yeah,
more
it's just
structured
GPT
form.
because it does M dashes all the time. So it's definitely GPT, but I suspect that it was used, that it's the same, if I had to guess, right, and also because I actually I don't have any internal knowledge, but I have had other people say guesses to me along the same lines that this is that the prompts that you have here are probably related to the prompts that were part of the captioning data, which would make a certain amount of sense because they would have the idea that, oh, you prompt this and you're going to get a better result because this is how we prompted the model. And of course I disagree because even a large language model like GPT, when you aggregate millions of songs, there's going to be patterns we can't recognize where it's going to be in a repetitive rut. But what will happen is the model that's learning will recognize and it will fit onto those. And so if you restructure it in a different way, you're more likely to get a better result. So even adding like curse words is something I do often in Suno, just because I know they won't be in, because no caption will put that in there.
And your goal is essentially like you are trying to get it.
Not to be weird. I want it to be good. I just want good. It's just that it's the same thing with image models. People have a lot of preconceived notions that have kind of overfit in the various communities because a lot of people have repeated them over and over again without actually doing. It's just because they kind of make sense on face value. Like, for example, one that I hear all the time is that these are the resolutions you should generate at. It's a very common one. When if you go outside of those resolutions, especially if you're using other methods to avoid overfit, and you specifically aim outside of those resolutions, like between them, you will usually get better results because you're going to get better generalization. Whereas if you stay at those...
Why would they recommend those resolutions?
It's because the training material was in those resolutions.
But do they think that leads to better results, but you think they're wrong, or you think it just leads to more?
Empirically, they're wrong, but yes. Not always. Like if you go over res, for example, in SDXL, you'll get double, triple eyes, long neck, all that kind of stuff. Of course, I generated 1600 by 1800 6-step SDXL on a 32, average pipeline right now. So everything that people say that is not supposed to work obviously works in that situation, but there's reasoning behind that.
What is good? Like that's the key question.
Oh, good just means accurate, like it's correct. Like you have 5 fingers every time, that kind of thing. Like a high win rate. Okay. Like no aberrations. You don't have high CFG artifacting. Obviously, they're subjective, right? I have subjective opinions about what is a nice image versus an ugly image. But for me, good. I mean, I'll show you after. I mean, I'm not going to show you on stream because it's a model that can generate both safe for work and not safe for work material. So if I put it on here, the chances of it generating something that gets me insta-banned from Twitch is quite high. But that's just the nature of open models.
An understanding for me and others watching.
Yeah, for sure.
Like, so in your experimentation, basically, like leaving aside taste and the subjective qualities of what you think you enjoy. You're saying that like objective metrics, for example, of image quality, like fingers and artifacts and stuff, are less when you don't follow the instructions of like the recommended formats.
Not
and you
always,
actually go outside.
But yes. Almost always, yes. It depends on like for example, even with models that have, so there are some models that don't, like an example would be the pony models. I hate the name, I don't like, but the point is, if you're an SDXL, you whatever. Pony is a huge deal, and it eventually got fed into every other model. Now, the captioning data was quite high quality on that. Unfortunately, it is so regimented so as to be like almost unusable in many situations. However, because it got fed into regular models, not safe for work models, but just regular models people use for like generating logos or whatever it is you want to do. Some of the ideas and concepts and basically superior language understanding ended up working into the natural language understanding because of some clever tricks people did. It's not even really clever tricks. I don't think most people are onto anything. I just think if you have 1,000 people in a room and all of them are doing random merges with random names and random methodologies, but everyone is also generating and recognizes when something works, then over time, you just have natural selection. The models that succeeded, for whatever reason, they're the ones who will be popular. It doesn't matter whether the person understood what the hell they were doing or not. It's irrelevant, honestly. It's almost like a bunch of people mining, like in the olden days. And eventually, out of it, you get good models. And those good models have common characteristics. So that's something I manipulate. But, or rather, I don't know what those characteristics are, but they must exist, right? If everyone likes them, then there must be some convergence. So especially if it's the same architecture, you have a good shot when you do enough merges. But anyway, that's besides the point. When you go outside of the normative, basically, system of prompting, in my opinion, or my experience, you do get better results most of the time. It's just because whatever they use to capture, like if they use what's that old Google one everyone used? It was it starts with an F, but a bunch of people use that one. And if you use that and you do a prompt, if you do the right things that they had in their image set, yeah, you'll get something good. If you do something outside of that, you want a different character or a different style, or you want something more artistic, or you want something more photographic than it was trained on in that instance, the chances of you getting some sort of artifacting, incorrect hands. The classic example I use with people when is Mona Lisa. Is if you try to make like a moaning Lisa Kudrow, you're going to struggle in most models literally because of the Mona Lisa. But if you negate Mona Lisa, you have an easier time. So there's just like weird things that people didn't take into account, like the idea that proper nouns don't generalize well. Proper nouns require like direct memory. That's like a waste of, such a waste of a very limited amount of parameters to have, proper noun usage in a model that's meant to generalize.
I think the concept of like, if there's just a lot of Mona Lisa images out there and you have an image model that's seen that a lot, and then you're trying to modify that, you're going to have a harder time.
Of course.
If the model has kind of spent capacity trying to just know exactly what the Mona Lisa looks like.
In this situation, the UNet itself will err if you get close enough to it in a way that you won't perceive. It's not even really relevant, the clip, right? If you get anything, because you have some shared tokenization, it'll bring you close enough that you'll basically get caught in an eddy in this space, and you'll get tugged slightly. You're not going to go Mona Lisa. But basically, my opinion is if there's anything that's directly reproducible by the model, in your case, it would be stuff like Happy Birthday. Things like certain melodies, certain two-tonal switches. There are certain things that if you can directly reproduce anything off of a prompt, in my opinion, that's just from, that's something that usually I try to negate. I find that I get better generalization when I negate those, and then when I have fine-tuning access, I immediately remove them.
I think maybe just going back to like even what is guidance, and like you said, CFG. So CFG stands for classifier free guidance.
Yes, sir.
Sure you know, but basically it's, if you have a model that is just unconditional, then your goal is just to get a sample of anything in that the model is modeling. So if you're trying to get an image out, like you'll move towards an image.
Right.
And then when we did the conditional bit, we found that like it works if you have an image with a dog and you ask the model like, okay, which direction should I move image of a dog? And it leads you there. It's not conditional enough. It's like, it's still kind of muddy and you don't get the clarity, and it's not doggy enough. And so the idea of classifier free guidance is that you ask for the direction to move that has the dog, and then the direction to move if you're just trying to unconditionally move to an image.
Right.
And then you take the delta between those vectors. Like you're still taking the same time step. It's just two different directions.
Right.
You take the delta and you make that delta bigger. So you're kind of saying, I want more guidance.
Right.
And that's the high dimensional arithmetic. And anytime you do that, it's essentially like you are going out of distribution of the way that the basic diffusion model is trained.
Yes.
Because you're like sharpening towards, in the incremental noising schedule, you're sharpening in a certain direction more than the model would ever have seen. And it's almost like the model will bring you back. But as a result, we just find empirically that leads to much better quality. And that's kind of just...
You can get more accuracy. You're just getting a more accurate vector. That's all it comes down to. By doing the non-conditioned versus the conditional. It's the same thing with the new STG thing they're trying out, which I disagree with. But by cutting out layers of the model, you're getting an inaccurate vector, and you're comparing it with your accurate vector. And basically, it's very easy to negate wrong. It's very hard to get right.
These are all basically like shortcomings of just where the state of deep learning is at, that these things help. Like ideally, the conditional direction in model moves would yield a better result than anything that's out of distribution for how it's trained. It's
I
actually
see.
quite.
I don't know that that's. I think you'll end up finding. This is just an intuition. I think you'll end up finding that that's going to be a hard problem, and I mean that in like the mathematical sense. Like it's going to be a problem that isn't. It's the same way. Like it's how I feel as an artist. It's the same thing. It's very easy to recognize inaccuracy. It's very hard for everyone. Even the best artists will say this. It's almost impossible to recognize accuracy. It's like you can't tell when you have something that's everyone's going to love, but it's very easy to tell when everyone is not going to love something. And so you have one problem that's trivial even for humans, and one problem that doesn't mean that a machine can't do it, but especially in machine learning when they think so similarly to us, I think it's a problem that they'll intrinsically struggle with. You might be able to have some algorithmic solution that we just haven't thought of yet, but I just don't see it. That's just me. I don't know.
Just forget about creative AI and generative AI for a second and back up to like, say the type of deep networks that I worked with trying to avoid obstacles, do 3D reconstruction, do object detection, do whatever else. Like you're trying to accomplish a task. So the most common problems that occur is when you are getting something at runtime that is different than what it was trained on, and therefore performance falters. So like the strongest body of knowledge there is like if something is out of distribution with how it was trained, it's not going to perform with as high of accuracy.
Right.
And that is like the fact that at least in diffusion models, doing this guidance inference trick helps improve accuracy and clarity, at least the way humans see it. Essentially means that it's not correlated. Either it's not correlated with the loss that's used for training, which obviously
I understand what the confusion is. Okay.
Activity.
Okay, so it's you see the same issue in natural. So okay, in a diffusion model, this is how I see it personally. When you're training it, right, it's a naturally selective process in a bizarre way. Of course, I see everything in that way. That's just my problem. But I see algorithms backwards, basically. So from my perspective, you have this starting. You think about it at any point in time, it's a mapping between your inputs and your outputs on a theoretical level. It's obviously not. We can't like actually list all the inputs and outputs, but it exists. If I give it an input, it'll give me this same output given some sampling and some time step count. So we have this mapping, and as you train it, this mapping is going to adjust. But any sort of system, it's basically under a selective pressure, which is your backprop, which is, if you think about it, every possible state that it could go to when it's changing, all the other states, right, in comparison with the one that your backprop picks over time, it's picking the one that's going to improve the loss. It's going to make it so that it gets closer to the correct answer, whatever that is. However, and every single system has this. You'll have, in humans, it's cancer. In biological systems, right, you'll see like birds that have wings so big they can't fly because of a weird mating ritual that went out of control. This is overfit. This is what we're describing. It's when you have, in a diffusion model, you'll have the same thing. There's going to be eddies or things within it that figure out how to survive that process you're using. Local minima is the other way we call it. So on the other end of things.
To me, local minima is more generally applicable than kind of overfitting in a lot of these cases.
Yeah. I use the terms incorrectly because I'm uneducated. but that's how I understand. I understand the concept. I just don't know.
Autodidact.
Yeah, yes. I mean, I understand I understand how the model works. It's just I don't talk about it with human beings. I just read. So
you understand the model works better than anybody. So
I don't know about that, but I do love the models. But my point being that what you're describing to me is expected behavior, and it's the reason why I try to prompt outside. It's the same. I expect the model to be imperfect. I expect it to always be a local minima. There's never like an optimal. I mean, there is a theoretical optimal solution, but we're not there. So it has to have an imperfect understanding. And so my goal, I can't. In other words, it goes back to the other thing. I can't push it in the right direction. It's not gonna. Well, you're saying it should always just flow correctly, but in reality, it's just not going to. It's always going to get stuck. There's always going to be an eddy somewhere that's going to pull it in. It's
like, let's think about we think about a simple example like the spiral. Like you can measure the quality of how well you map the spiral distribution. Like you could say, this is my source data set. It is the spiral. I'm going to train a model now. To test it, I will run 1,000,000 points from the normal distribution, and then measure how the distribution of what I generated differs from the data set. And
Okay.
there's, for 2D points, there's very simple measures, like you can do clustering and take differences there. You can compute a couple of different metrics, and they'll kind of tell you just like unconditionally how well did you model the density and the distribution of that data set. And the reality is like we're like that can be measured and solved for simple cases, but in the complex cases of, let's say, music, high
Yeah.
quality music and audio, like there is no good metric that
Mm-hmm.
will, like there are ways to measure how close it gets to the data set, but to measure you need a metric. And
Right.
if your metric is, say, the um, distance of like you subtract one waveform from another, it's going to be a complete shit show, right? Like
Right.
completely
It has to
meaningless.
be preference
Um,
based. That's the only way.
if you use like spectrograms and low resolution spectrograms, like it maybe is one song close to another, but you will
Oh, you're
never
talking
you,
about for
you
CFG. Okay.
sure. I'm talking about like if I generate let's say 100 million outputs
Uh-huh.
unconditionally
I see.
from a fuzz model,
Uh-huh.
like what will be the total distribution of that? And does that
Ah,
model all
interesting.
things that we want our users to generate?
No,
Um,
certainly not.
and certainly not. And that means that the learning process is imperfect. But
Of
for a
course.
simple example, something lower dimensional, something similar, like you can measure that and
Yeah.
you can accomplish that. And so a lot of the like stuff going on empirically is really trying to bridge that gap. And the
I see.
tech will get better.
So that's on your end. You guys are on the on your end, basically trying to your whole shtick essentially, because that's y'all's job is basically figuring out how to consistently bridge that gap, like 100%, so that whatever I prompt it gets better or gets closer to, or ideally I don't
Yeah,
have to
it'd be
prompt
like
anything. It just it just goes to good. But
if you don't care what you want to get and you just prompt unconditionally, the goal would be to generate something that's beautiful and
every time
aesthetic and interesting and clear and sharp,
I
which
agree.
is completely different. It'd be like if you just sampled, one random user of Riffusion, it'd be like something that they thought was incredible. And then the next one would be
Right.
a completely different
And
genre and
everyone should
aesthetic.
ultimately be represented in that, basically.
And then the goal of controllability and the prompts and everything is like explore that
I
space,
see.
but everything in that space is incredible and interesting and beautiful. Like that's where we want to get to. And
Well,
then
that's
we
why I
have this
like
latent
merges. That's
space.
why I find them beautiful. Well, they're not the way people do merges is there's a lot of challenges because the problem is they're lossy the way that they're designed. But the big thing that I find with merges that is cool with you guys, it's more challenging. You guys can do stuff internally, but you just like that's just tinkering. But merges are if you have a bunch of models competing, like we just talked about, it's like meta natural selection. You have all these different models where internally their training process, right, is a process by which you get the best version of some possibilities. And then, although, that happens more directly using backprop. But the less direct one is people choosing what model they like, human preference. Same way with songs. And so this human preference creates a pool, and that pool is going to have some intangible commonalities that humans have difficulty basically keying in on. But the model's weights, if you have enough of the models like that, some of them will, like I said, it's mean reverting. So the weights which are only rarely represented are going to slowly decay, and the weights that are highly represented are going to be strengthened over time. And so you have a selective process that helps to preserve quality. But it depends upon user data, basically. Or in the case of something like Civitai or Hugging Face, a whole bunch of people doing a whole bunch of work at the same time and really caring, like very deeply about the quality. So anyway, you guys are doing very well with the rate of improvement. I also want to note to people listening that Vibes is, to me, the same. Vibes and generation on the inference side, I see the same exact commonalities where this is why this part is important. I mean, this is the part that I deal with. Inference side, the way that you take generations and move them forward. For example, right, I should just be able to cover chain a gen along its own style, right, and just get more of that. But what ends up happening is I'll get caught in an eddy. At some point, right, the model has some understanding that is flawed somewhere. And if I continue in the same direction long enough, my likelihood of reaching that flaw increases, and it's going to pick up and collect in my song. Sometimes in ways that won't be audible to me, because the song itself is going to hold data that's relevant to the model. It's just one of the, because number one, it has different, obviously in the diffusion process, it's learned to pick up contextual cues from itself. So intrinsically, it's carrying information, which is something you can leverage, by the way, if you cover chain using differing prompts that are associated with high quality, because essentially you can bake in a more global goodness by sort of collecting.
Backing up, I think the fact that you can merge models and kind of get their aesthetics that's just like
it's wild.
That's like a miracle. That's like a miracle of the universe, and it's a very mathematical truth, and that I feel like I've learned to appreciate through my whole career, which is that
it's incredible.
As you take a complex problem, like if you write down a very complex set of equations on paper that would have like a very spiky like loss landscape, a very complex solution, like to optimize it, you would need a very sophisticated like small optimizer. If you take all those variables in that equation and you project it into a very high dimensional space, not even very, like I could write you an equation with like 10 variables that's like very hard to solve. And if you then project it out into 100 variables, actually you can just do you can do very simple first order optimization, second order, aka like gradient descent or Levenberg-Marquardt or something like that, and get to a solution very easily. Because you just have so many, you've just projected out the complexity such that taking like incremental steps in a high dimensional landscape gets you to the solution. And that's just like one of the key intuitions for any deep learning problems. Like if you have enough neurons and a very simple but robust optimization scheme, you get the universal function approximation.
Right.
So in the same
universal,
way,
that's dope.
In the same way, if you have like direction to move in a high dimensional space and then another direction to move for a different goal, and you average those directions, you get something that's kind of in between them. And
right.
that's what makes it possible to say combine two random ass vibes with, different characteristics and get something that is an interesting mix of them, or say I want more of this one and less of this one, and that.
Well, it's also dependent on y'all's model. It's some models will struggle with this. So if you guys have any sort of merging process, this would explain a lot, because I find that merged models tend to do better with merging prompts. I don't know if it has to do with the smoothness or something, but in essence, y'all's model responds quite well to combined prompt methods, which is one of the things I do like about it. Of course, any good model should. That's the reality. If it's very rigid in its responses, it's not going to create creative new things. It's going to only be able to reproduce basically existing material or similar to existing. Y'all's, you can do creative things.
It's all about how it's trained. Like again, if you train a model in a very structured way, then it will probably struggle to go outside of that. So the more you train a model to be robust, meaning you get a diversity of things, and it's perturbed in various ways and it's augmented in various ways, then it will handle the kind of out of distribution stuff better.
Okay.
And I think a good example is like if you are trying to combine two vibes with two different tempos.
Yes.
Or two different keys. Like what the hell is supposed to happen?
That's a good question.
And that depends a lot on how the model has been trained.
Interesting.
And if, for example, if you train a model such that like you tell it what BPM to use, and then it's always that BPM, and then you tell it another BPM, and then you try to do like guidance between them. Like there's a world where it averages the BPM and you get something in between. There's a world where you just get chaos because you've got two competing directions, each with their own BPM.
Right.
And they basically they don't get merged. Instead, they just compete. So the competition aspect of like moving through the latent space is something that's usually best avoided. And when you do something like alternate like this crazy prompt with this crazy prompt and go back and forth and then
Right.
upload it to this website or whatever, you're kind of zigzagging
Yes.
the development in a way. But if you do two at the same time, it hopefully will go through the middle or something like that. But
Yeah.
if instead it's like internally competing too much, then you can get chaos.
Yeah.
And that's all quality of kind of a bunch of details of how the models are trained. And one interesting, like you can do that at the level of like creating an output and then editing the output, or you can do that while the generation is happening. And the more powerful way to do it is while the generation is happening, because the like partially noised, partially generated latent space of a strong diffusion model is like it's a beautiful thing. Like
Yeah,
you
it's
can do a
more
lot.
right. It's not well because
It's
the Gaussian. It's the way that they're trained is basically to denoise specifically that particular distribution, is my understanding. So if you're taking it, if we put it back into the latent space of the VAE, it's not quite the same, and it's not going to be able to get out of it as easily.
Yeah, it's tough to talk about because it's like it's a very hard thing to expose in a
Right,
product,
right. I understand.
but
Yeah.
it's like stem cells. It's like unfired clay. Like once you have the audio, you can go edit that and do all kinds of fun stuff with it. But when you have like something that is like a 10% developed song in the latent space, there's so many directions it can go, but it
Yeah.
also has its characteristics. And providing like intelligent guidance at that stage is really is really powerful. And I think that's one of the things I just love about diffusion models. Like that stuff exists.
Yeah.
Whereas with
Growing
language
songs,
models,
in essence.
with yeah, with LLMs and language models, like you're predicting the next token,
Right.
and in that case, like the inference and the geometry of it is quite boring in comparison. It's like you've
Yes.
got a set of possible next tokens. They have probabilities. You pick one, and you run it again. You get the next one. But
Well, I also like that it's
the
non-temporal, or even if you have aspects that are temporal, it like the not like I love that component of it because the reality is when you're putting together a song, I don't know anyone who's ever done it temporally. Like yeah, and it technically like you go, but like no one finishes the song the first time, if that makes any sense. Like you're constantly like sort of going back and forth and exploring it. Obviously, and also the other component I see is I feel like it's very limited to our expectations as humans to do things temporally. But like why? If we don't have to, if you can go both direct, or like basically look at the entire song as one thing at one time, just seems intuitive to me that that long term is going to be really interesting and continues to be. I mean, yeah,
I see it both ways. Like if you're a jazz soloist, or if we're having this conversation, like we are kind of spitting out one token at a time,
right,
and then you're getting what you got, and it can be awesome. But at the same time, if you're trying to create like a masterpiece, you would never do that, right? You go back and edit the podcast, or I think about what I'm going to say before I say it, which, once in a
well, it
while.
does think.
Uh,
That's the thing. Its exploration, its baking time is in essence its equivalent to
yeah,
a pre because it doesn't just pop it out in one step unless you're using a
right,
very specific type of model. And generally speaking, there's a
right.
denoising process, and that process gives it an increased win rate, i.e., it's equivalent to thinking functionally. It's just not the way we consider thinking because it's not readable. Um,
Yeah, so you could argue that a language model would first kind of attend over what it needs to do and then kind of reason and then spit out the first thing and go in order. But in reality, most language models spend the same amount of kind of time thinking for every step they take.
yeah,
And so if you think for X amount of time, then spit out the first token, then X amount of time, spit out the second token, it feels kind of like a bad distribution of how you're using your compute.
right.
Because by the time you're on the like 100th token, that one might just be repeating the chorus again. Why are you spending so much equivalent time thinking about it? Um, so the idea of having this like structure slowly come together from noise is an interesting kind of more holistic way to be like, okay, I'm gonna, attend to developing this piece of it slowly, incrementally. And there's challenges with that too, but I think it provides a much richer canvas for all this kind of editing stuff for
Yeah,
having more control.
the sound certainly
Um,
is good. I like in terms of the fidelity and stuff. I mean, now you guys the only other model that was like it stood out to me right away when I first used Riffusion, because I've used Udio, I've used Suno, I've used whatever. Udio, in my opinion, for a long time, a lot of people would be like, oh, I don't know, but they just hadn't tried it, was better than Suno in terms of the audio fidelity, without a doubt. When I came into Riffusion, it's like I had the audio fidelity that I wanted, but also it wasn't a real hard to use. Sometimes getting the audio you want out of Udio can be a challenge in comparison with Riffusion, because it almost feels like you guys have a backbone in there that kind of pushes you through. So it's good. You get the best of both worlds from my uses. Obviously, you guys are still, everyone is moving fast, so I'm looking forward to seeing what everybody does. I'm hopeful that, look, if they blow you guys out of the water and then you blow them out of the water and it just goes back and forth, I'm just going to have great music. So I don't, I want everyone to just like keep making cool stuff because the music is great.
Yes.
All right. So the question, we got off on a tangent on whatever. The other questions I have is, we basically talked about vibes. Oh, is it? I had a question. Is it purely drawn from that 10 seconds, or is there like more to it, or is it really just that 10 seconds that you have on the vibe?
Yeah, I mean, there's a lot to vibes, but
does it draw from the whole song,
vibe,
or
yes.
is it really just the 10-second cut? Does
No,
it matter
just
that
the
much?
10-second cut.
It's just the 10-second cut. Okay.
If you click that 10 seconds and you uploaded it, like it'll be the same. Like
that's incredible. Yeah. So vibes still blow me away. The way they made me think about y'all's model, that I will never forget. Like when I realized that, like I was like, oh, this is basically just like compressing, like because it contextually has information from the rest of the song. Because number one, because it's diffusion, so it's not just going one direction. Presumably. So it's not unless it's diffusion in a temporal sense. But anyway, I don't know I don't know how that stuff works. Actually, I haven't looked at any of those models that are between the two. But
it's really just a super powerful like audio guidance. It's like you will never get as specific with text as you can with an audio snippet.
For sure.
And just being able to use that same mix and match strategy and stuff with the snippets is, I think, a big part of the future. And there's so much more you can do with that we're excited to explore. Like
awesome.
The idea of having an aesthetic built out of a mood board of your sounds and a bunch of descriptions, and being able to kind of use that as a weapon to generate, in your aesthetic, and then mix and match those and build those up. Like that's, I think, ultimately a community-driven and more powerful way to do it than kind of merging weights, because it's a hell of a lot easier than merging weights and lets you keep a very powerful foundation model. And so I think evolving from like mixing and matching vibes to mixing and matching like compound aesthetics built from all of these things and also personalized is super exciting direction.
Vibes were my favorite thing. Once you guys have whatever the next vibe update is coming, I'm about it. The vibes were like probably my favorite component of Riffusion. Well, actually, Sir Biceland just commented. The other thing is the replace. Replace is like, there still is like literally nothing else that does replace like Riffusion does. Okay, so last thing I had was, two things. One is Sir Biceland wanted to ask before, are there any myths that you guys see in prompting that you guys are like, well, that's just not true? Or like it's just like anything that you guys are seeing that, even something that I'm doing, I don't care. I'd rather learn if anything you see that people are blatantly like, that's not working. Or there's no merit to that concept, I guess, essentially. And you're welcome to name names and like talk, no, I'm just kidding. Don't. That's, but if there is anything, I mean, obviously I think most people want to know because they want to be able to prompt effectively.
Yeah, I'm thinking. Hey, Stare Bites a lot. Thanks for the question.
Yeah, he asked me this, or she, I don't know actually, asked me this like a week ago when I first was scheduling this up. I just asked her.
Yeah, it's really hard for me to, stand on a pulpit and be like, this is wrong, this is a myth.
It's okay, you don't have to, but it's worth asking.
The most obvious myths, like, it's not an obvious myth. I think the most obvious thing is like when people are like, I know that I was using this model and it changed,
Yeah,
or
yeah,
like day to day, like now the quality is total shit, and like what's going on today? And it's like, well, you might be in a different mood,
right.
and of course, like sometimes things change, but like
Also
of
stochastic.
course behind the scenes, like we can see what's happening when we're updating models, how we're trying to make stuff better, and like cases where someone is just so sure about something and like nah, like that didn't happen.
That just didn't happen.
And it's that's the most common like myth. And I think kind of somewhat related to that is just the gap in always trying to figure out like what model is better for people in what way. So like we do lots of blind evaluations. We try to cover different use cases, different users, but how the heck can we know about like every language, every taste of
Right.
somebody, every prompt? And so I think it's fair to say like every model is different, and newer models, like, if we're doing our job, should be better for most people. And from our perspective, it can be better in every way that we can kind of measure. But there's going to be people that preferred the old thing, and I think we're
Right.
kind of like understanding that that's totally okay. But if that becomes like, then a vocal minority, it's like, okay, this is a total downgrade because of these reasons. It's like, okay, well, I mean, I think that's can be true
Right.
for some specific use case,
Of
but
course.
and on the whole, like we have to think about just
The
yeah, what
majority of
seems what
users.
seems better all.
Right.
And that includes like as much, weird creative stuff from the top creators as well as like first time users. If anything,
Right.
I think we're most interested in the top
For
creators and
sure.
enabling like this ceiling to be as high as possible
Yeah, that's
because it's
definitely
like
clear.
it's a power law thing. It's like you want the most amazing stuff and not like maximize AI slop in the world, right? That's not our
Right. No, that's
mission.
not the goal here. Yeah, I think
But the
even people
goal
who
is
are
like
new
anybody
don't think
is
of it that way. They're not like, I'm coming in here, I want slop. Like nobody's ever bought a product
yeah,
because they're
yeah.
like, I want garbage. Like I want the worst. I just want it to be fast and cheap. Like
But you want
for
like
my
you want a
music.
good first time consistent experience, right?
Yes.
Like you want somebody that played an instrument when they were a kid, like interested in music, but never thought they'd make it to try it out and like not get something like bad. They're
Yeah.
like, okay, now I have to read this tutorial from Yolkhead about
Right. Oh,
merging
it's
those
six
two
hours
models,
long, and
100
he's talking
TFT.
about like
Yeah, yeah, yeah.
CFGs.
No, I'm gonna bounce and watch Netflix instead,
Yeah.
right? It's like you want those people to have a great experience, but then have like a ladder into just discovering how insane and awesome this stuff is and the creativity that exists. And so
I think that is an
the
area
whole
you
kind
guys
of
can continue to work on. From my wife is my gauge for that aspect. She loves like a lot of the same things as me, just in a different way.
yeah,
And I will say, once you guys capture her attention, then I think you'll have that. She's I think depends on the genre. I think when you're a first time user, it goes really well, or it
yeah,
can go less. It's just like you have to. I feel like there is a higher ceiling, but there's also a higher difficulty at the start. This is something else I saw with Udio, but I know you guys will work it out.
yeah, for
There's a
sure.
lot to
But
do.
back to myths, I think yeah, I think I really like I'm hesitant to call out anything as like this is bad prompting. So who am I say to that? Like it's art. Prompt however you want. Like some of it's just like people reading your prompt after the song is made impacts the experience of it.
Right.
So there's even an aesthetic element, but probably some of the weirdest, funniest stuff is like when I first noticed, and I'm sure this was common on other platforms, but when it started happening in Riffusion, where people will like put on like arrow emojis to
Yeah.
like describe rhythmic patterns at the start,
Yes.
in the middle, and be like, if that works for you, like sick. We certainly haven't put in like
Arrow emoji
rhythms
training.
and as emojis
So I will
in
tell you
training.
that I know the birth of that. I know when that started. It was not. It's not a Yolkhead thing per se. It was everyone, but it actually. I think the real place to start it was like there was several big community members that basically, essentially, were like shamans, but like AI. So they started putting all these emojis and all this other crazy stuff. But the thing is, so the model was like at that time was super overfit and had a lot of issues. And so you would notice that like it did improve reads. It didn't do anything that you told it to do. But that didn't actually matter. So I just started putting it's like you might have seen when I first started, I would do like verse, chorus, song music and like a bunch of different tags on each one and improved read quality. because I know from my own experience that most models, especially when it's like whatever, they'll be overfit on each of those tags, and it's gonna like make the read very particular. And I don't know what I know what a verse is. I don't know what the model thinks a verse is. Like, does it think that because in practical terms, does it think it needs to pause at the end? Does it think it needs to pause at each line? Does it depend on the genre how it's going to interpret that tag? There's no way for me to know because that word doesn't actually have semantic meaning to a human being. So it's a shitty tag. I'm sorry, it's a bad tag in my opinion, as are basically all those ones. So my goal is to get rid of them as much as I can, get them out of my face, and get it to get the model to do what it's best at, which is reading better than I ever could. And so, in those cases, those sorts of weird emojis and stuff actually can sometimes be helpful. Just because,
That's amazing.
but
I'm watching. The whole team's watching how people prompt and what's interesting.
but it's not
and, like,
specific.
it's
It's like you'll have a
yeah.
song that you're struggling with, and you might randomly stick like a random series of emojis at the front, and suddenly it works. And then you discover that if I reuse that emoji series on another song, it also seems to work, and you can test it with like the same seed. And I don't know why this set of emojis seems to work for some reason, or if I put the F word like right here, it like always does things right. But it's just I don't know about y'all's model. This is on I'm assuming that the conditioning in the lyrics affects the song. If that's the case, then I imagine that it doesn't really matter what the tokens are. It's basically like running across a human. Yeah. So what I always call it's like community-made embeddings. Homemade, like you can train an embedding by finding it using backprop, but you can also find an embedding by having 20,000 kids and teenagers like put random characters like a monkeys at a keyboard, and then you find the good songs, and then the other people who are like paying attention start copying those things, and eventually you find one that really works, and you're like, oh, like Quabalabulous, that's a good one, or tennis in the case of some of the other ones.
Yeah, you got to catch them all like Pokemon.
Yeah.
Yeah, I think it's both, like it does something, and that can be interesting.
Right.
And I also think you can separate like technically what does this do and empirically measuring it with like it's just a cool, fun thing to do with your song, or it makes
Right.
you happier with your song, or it makes other people think the song's cool to look at because it has this thing.
But it's
And
not following
there's
any
not
instruction
necessarily
there.
a reason to separate those things because it's
Right.
like it's music, it's entertainment. Like you made a song and you love it, and you like associate that with the process you went through and what you put in and your tricks. Like that's actually sick, and other people
Right.
might too. Like there's a lot of great music out there, and the like aesthetics of what it's called and what image it has and what it feels like and what venues it's shown at and who promotes it, like all that stuff makes a difference. And so it's just like the whole canvas of listening to a song is not just the waveform,
Right.
but everything.
It's like the whole
the
experience.
experience.
Yeah. 100%. A lot of people have, I've even done this in the past, but like, yeah, basically making your prompt itself into sort of a part of the performance art. Things
Yeah.
like that. So yeah, it's definitely a new thing because that wasn't really, you didn't used to prompt. So instead it was, playing behind your back or whatever.
Yeah. So now we got the remix tree. So people that are kind
Yeah,
of,
that's awesome.
willing to have their songs be open, then it's a lot easier to kind of scrub through and start understanding like how the heck did Daniel make this thing.
Yeah, it's great. Does it go through vibes too, or that it cuts off at the vibe start? I haven't checked through it that far because I already know how well myself.
Yeah. If you generate with a vibe, it'll be in there. But if you take
Okay.
one song and you use it to vibe as a vibe to create another song, I don't think that's going to be in the
You don't think
remix
it's going
tree
to connect?
currently.
Okay, I'm just curious.
But I think a big part of like what we want to be able to do is say that you can create some set of cool vibes, and you can kind of actually make those available for others in a more direct way, and then you could, as a vibe, as an entity, you could see who all has used your vibe
Yeah,
and
that's
kind
awesome.
of track that. I think that'd be a really cool community thing that we're interested in.
Yeah, getting the
Um,
lineages, I think that gives creators more credit. People like cred, like in these communities, that's like the main currency, basically.
Yeah.
So like when
Yeah,
people like
in
use
the
your
reverse,
stuff,
like
yeah. I mean, some people want to hide all their
right now
stuff.
the remix
I don't know why, but the whole point is to have people like want to use your stuff. Like, that's where the quality is. So hopefully it encourages the community to do that.
Both ways. It's like what was done to make this song, and then the flip side is like, I have a cool song, like who all has remixed it and what did they do with it? And so that's
Yeah.
that's super important. Well,
That's as well, yeah. That's also, and then it also helps you with discovery, which is always a challenge on like every platform. Last thing was weirdness. What is weirdness? Do you guys have any insights into what weirdness actually like I said, I've said before, like I feel like turning down weirdness increases the strength, but it also does some other stuff. Like it feels like it also increases its tendency. If I turn weirdness down for too long, it bakes something into it that I actually find is it starts to basically overfit. If I turn weirdness to zero,
it's
for
less
example,
weird, man. Makes it more normal.
it makes it too normal. Normalness baked in. It starts to wake up at 9 and go to bed at 7. But no,
Yeah, exactly. Why'd you turn it down if you didn't want it to be more normal?
Yeah, but it's just something I've noticed, and I just was curious if there was any extra insights you could give us into weirdness, or is it just like a thing that you guys don't want to expose outward at this time?
Yeah, so just stepping into the dark dungeon of the models and the process of running inference, there are a lot of variables and knobs. Like we have quite a sophisticated stack for like how we are generating these things, and there's a lot of controls in there. And of course, we have to balance like making a beautiful, cohesive, understandable product with how crazy any of these sliders are, with essentially just allowing control for people that want to go deep and play in the sandbox. And so the controls that are exposed in our app are essentially kind of think about it like an API that goes to the models and does something. And so weirdness is the most like lyric strength, strength of a sound prompt, the strength of a cover, like those are in some ways more like directly understandable. So weirdness, it's weird, it's a slider, and in we kind of reserve the right to like it's kind of mapped to various things actually depending on the model. We're trying to make an experience that is like roughly correlating to the idea of weirdness. Like if you turn it up, you'll get more diverse, more strange things,
But not
maybe
bad.
more chaotic,
Right, maybe more
more
chaotic, but your
unpredictable.
ideal is that the high weirdness shouldn't be like bad sound, but the low weirdness
It's
or
also
should
gonna
it
be
be
bad
potentially
sound,
bad sound?
yeah.
Okay.
But low weirdness will be more consistent and on average probably
Higher win rate.
maybe not in the extreme, but on average probably a more of a sound that more people like would like in a pop sense. And
Right.
high weirdness will be more experimental, right? And so
Okay, that's
that
cool.
there's not only just the models, but there's also like the not just the weights of a model, but all the like setup of how we're running inference. And within that, it's like each of these setups implements weirdness in a
Differently.
way that we think is interesting and
Okay.
roughly in line with kind of like what we want this concept to do.
I see.
So there's a world where we could make 10 more of these sliders with interesting adjectives,
Right.
and call them things, and like at least a dozen people would
Use them.
find something to do with them.
Right.
But yeah, I think that's the short answer. Is like,
Okay.
yeah,
It's
I
got a
think when you're
lot
doing a
behind
bunch
it, but it's different for different things, so it's kind of hard to. But essentially, it's just a slider that you're basically abstracting away some extra stuff that's somewhat variable. It sounds like, depending on the task.
yeah, I think Midjourney is very similar in what some of the controls that it has,
Yeah.
and I think at the end of the day, like if you use higher weirdness, there's more of a chance of happy surprise, more experimental outputs. Like it's different if you're doing comprehensive like edit chaining and stuff, then
Right.
you can layer stuff on and so on. For a one-shot generation, I think that's where like mostly I can say that if you use lower weirdness, you're more likely to get something poppy maybe more likely to get consistency and rigid structure and maybe even clarity. But high weirdness is more likely to be creative, unique, and it's just something that we'll keep on kind of working on.
Cool. Okay, awesome. Well, that's basically all the questions that
Yeah,
I had. We've gone like for forever, so I'm sure you have to like.
went forever.
Yeah, yeah. This is a lot longer than I anticipated, but yeah, it's been a lot of fun. Well, for me, you got to answer a ton of questions that you already have
I
answered
have fun.
dozens
Yeah,
of
time
times.
flies.
Okay, all right, cool. Yeah, that's basically it. If anyone, I mean, I think the chat already said anything that they had to say. It's mostly right now Sir Bites talking about the different like lyric stuff we were talking about before. But yeah,
Yeah.
thanks for explaining. Yeah, also I have some stuff to think about in terms of just some of the model stuff you said was interesting. And if you are interested in 30 model merging with, six-step high CFG, I'll send you a workflow from CompUI. No, I don't use any custom nodes. It's just regular default CompUI nodes. This is a workflow. I'll be putting this out in the coming weeks. I usually do a model when I release an album because it's a good way to feed everything together. So, and I'll be coming out with an album soon. Speaking of which, I got to contact you guys about getting rights to 3 songs. So there we go. But we'll get that worked out.
Sweet.
Anyway, awesome. All right, man. I guess that's it. See ya.
Thanks for the chat.
Thanks for the chat, dude.
Listening, whoever. Check it out.
Awesome. All right. Have a good one.
See ya.